We're live. Hi, guys. Thanks for coming.
Hey,
Today,
how are you?
Yep.
good. Today, I thought maybe we'd talk a little bit about some of the reasons people are seeing heat exchangers fail, because it's been brought to my attention that there are more than just one or two. And then I also wanted to talk a little bit about accuracy, which is why I have this accuracy thing here, because the reason heat exchangers fail and getting to a certain level of accuracy are going to tie together.
Mm-hmm.
So I'm hoping you guys will help me with making the bridge from heat exchanger failure to accuracy and the importance of downsizing equipment to avoid heat exchanger failure.
Can do.
So one of the things I think, and I guess it was Jason Trammell sent me the picture that I used today, showed the heat exchanger cracked. And you see that cracking, it could be, what did you call it? Metal fatigue due to becoming brittle?
Yeah, excessive expansion and contraction makes it brittle, and then it fails. So yeah,
Okay.
metal fatigue.
Turns out a lot of furnaces, particularly, and this is counterintuitive, or it was to me anyway, as it gets colder, the thermostat on oversized equipment has less and less control of the operation of that equipment.
Well, it's supposed to be turning it on and letting it run until it's satisfied.
Right.
But when you don't have enough airflow, either because the ducts are too small or the furnace is too big, or both combination, then the high limit will cause in many models will cause the burner to shut down. In some models, it'll break 24 volts and blank the thermostat, which still shuts down the burner. And then the fan runs until it cools the limit down, and it closes, and then it can start the burner cycle again. So in most cases, the homeowner's not aware of it because the blower's running and it's warm air coming out.
Right. So the gas valve is getting shut off, but the blower is still running.
Yes.
And so that blower is struggling to cool the heat exchanger off down to a safer temperature.
Yeah, within the design.
Within the design.
Mm-hmm.
So that equipment is going to an overheated state and then cooled off, and then overheated state and then cooled off, and an overheated state and then cooled off. And if the amount of BTUs coming out of that equipment doesn't satisfy the thermostat, people can actually end up going backwards. Even though the equipment is possibly plenty big enough to carry the load of that house, because the ductwork doesn't allow the BTU to be removed from that heat exchanger, it keeps going into high limit and shutting off the gas valve.
Yeah.
Not removing the BTU fast enough, overrunning, and you may not realize that problem in lighter load conditions, although that problem is there all the time.
Yep, quite often.
Right? I mean, in that circumstance, that overheating situation is likely to be there all the time, because when your return air on a more mild day is hitting that heat exchanger, it's not transferring as many BTUs because the return air is not as cold.
Certain air is not as cold.
Right. And heat goes to cold, and the bigger the delta, the faster that
Oh,
transfer
yeah.
occurs. And on the coldest days, that return air is likely to be colder than on milder days. So there's a good chance you're hitting that limit even on the mildest days, because that return air is doing less of a good job of cooling that heat exchanger.
It's really like longer run times is what make it hit the limit, not necessarily the temperature of the return air. It's usually, most people leave the temperature of their thermostat about the same regardless of outdoor temperature. So it's more of it having to run longer because there's more of a load on the house. So it's hitting limit more frequently than it would if it's only running for 5 minutes, an hour, or whatever when it's not.
Okay. Yeah. And then in that circumstance where it's mild temperatures, that equipment is running so short, there's a good chance of condensation occurring within the heat exchanger. Do you want to talk about that a little bit too? And how over time that can cause the heat exchanger to rust out? Because we're seeing rust and we're seeing cracking, and then we're also seeing both in these pictures of heat exchangers.
Yeah. Now those pictures of the ones that Jason sent, largely those were rooftop units, so they were 80%, and they're not designed to deal with condensation.
And and most package units have the cooling coil upstream of the heat exchanger, which is the opposite of what you would do in a furnace air conditioning split system. So all summer long in our climate, the heat exchanger, the inside of the heat exchanger is open to outdoor ambient air, and the tubes are cold because the air is cold. So it condenses all summer long inside the heat exchanger.
Oh my goodness.
It rots it from the inside out, which I'm pretty sure is a manufacturer's design to sell more units, because if there are some, and there has been in the past, units that have the heat exchanger downstream of the cooling coils after the heat exchanger. So it doesn't have that issue, but the heat exchangers last virtually forever, and that as long as the ductwork's correct. So they swapped it up and made them rot out sooner because they weren't selling enough units apparently.
Planned
wow.
Oh, that's
obsolescence.
That's a conspiracy theory, Jason.
Yes, Jason, that's definitely a conspiracy theory. A fairly provable one, because why else?
Yeah.
They claim that they can't get higher efficiencies, that they need to meet the regulations with the footprint with the heat exchanger.
Oh, so it's government's fault.
But you know,
it's like, well, we had to do it that way in order to meet the efficiency requirements. And so, of course, you're going to accelerate the rotting out of your heat exchanger because we're trying to meet the mandates.
Yeah. So, pass the buck.
Yeah.
I don't know that I've seen one with the heat exchanger in the Airstream first.
The Yorks or Johnson Controls
Oh.
package unit up until like 2012. It was in there. The Goodman package unit. It's still to this day the heat exchanger is not in. It's in the return side of the cooling coil. Seems like there's one other one that maybe Ream, or maybe there was a Ream.
There's a lot of ICP and Train around here.
On the plus side, you could trigger that gas furnace for reheat.
Yep.
If you wanted to add the controls.
Rot it out even sooner.
Oh, right. Probably.
Yeah, you can.
So condensation and thermal shock is really what's happening.
And with too small a ductwork and overheating, all that really fast heating up and then going off on limit, or just short run cycles of it cooling off real quick and then heating back up real fast and cooling off. And it all expands and contracts the metal and causes cracks.
Right. Which recommends smaller units so that they'll run longer and you'll have fewer cycles.
And,
And
lower temp rise, or
Yep.
not lower, but at least in the middle of the range that they're designed for, not 1 or 2 degrees below the max design, which most of them are running at. So
yeah,
but when you get to that point, then you're putting out like heat pump air temperatures,
right.
like 35 degree temperature rise, like a heat pump would, versus people are used to furnaces, 70 degree rise, or even on older like atmospheric drafts that have 100 degree rise or whatever,
Actually, one instructor said that he favors. The discussion was on staging furnaces, and he favors having second stage operating closer to high fire, because his thinking was, would you rather have a nice hot blast of air and then let the house cool down, or do you want to have lower temperature air delivered all the time? And he favored the first, hot air, big blast of air.
Well, I mean, that's with gas heat. That's the most efficient way to get the BTUs into the space is getting it in there fast. But it's not the most comfortable way. But as far as like combustion efficiency goes, the best way is to get the BTUs in there fast and then shut the gas off.
Right. Well, and he was correct too that low fire is actually less efficient.
It is
percentage points.
Yeah, because you can't change. You can change the volume of air with the combustion blower. You can change the CFM across it, but you can't change the size of the tubes. They're not very, very. So you have a small flame in there. It's not going to heat the surface area of the tube as quickly as if you've got a big flame in there heating the surface area of the tube. So the transfer of heat is, you lose efficiency doing that.
Right. So you've got a trade-off between comfort and efficiency.
Exactly. That's why you never sell multi-stage gas equipment on efficiency, because it's less efficient to run it in lower stage, but it's more comfort. It produces more comfort.
Mm-hmm.
But there's trade-offs there. I mean, your heat exchanger, I don't know, if it's an 80, it probably won't last as long as if it runs in the high fire. But if it's a condensing furnace anyway, you're probably not going to condense in the primary heat exchanger. So,
yeah.
But you could at times. I mean, you've seen rusted out vent pipes and on atmospheric draft and 80% stuff. And
sure.
Heat exchangers rusted out from condensing and when they're not supposed to be condensing.
Well, rust is actually an indication the furnace hasn't been firing properly.
Mm-hmm.
So
it is.
That should be the first clue.
That's because, I mean, nobody does combustion analysis in reality. I mean, other than very few.
Yeah.
So if they did combustion analysis, they would know that they're screwed.
Right.
So a lot of times they don't want to do combustion analysis because they'd rather not know.
Yeah. Because then they'd have to fix the problem and
they'd have to downsize.
Smaller equipment. Or just commission. I mean, take the time to commission the equipment.
What? Spend more time on the job? Bite your tongue, Jason.
You got to be done in 8 hours and go home.
That's right.
And get paid.
Got to get these trucks rolling.
Yep.
Sorry, we're hearkening back to the old stuff that was driven into us.
Yeah. But it's the reality.
It is.
I mean, there are some companies that commission stuff, but they're in the residential sector. There's not very many that actually do that.
Oh, and well, several of us watched the video of Corbett Lunsford.
Oh yeah,
and he said he was pissed at how much oversizing Manual J does. That Alex Meany was commiserating with him, and saying that
What?
Yeah.
Yeah. What was your take on that?
uh,
Does that seem to go against the sort of what the standard narrative has been in that space for a long time?
for a long time, it was all about the manual J, and you had to do the manual J. But one of Corbett's comments was that his parents have, I think they have, I'm not sure if it's dual fuel or if it's all electric maybe it's all electric with auxiliary heat pump.
Yeah, I think it was like a Mitsubishi Hyperheat
Yeah.
system.
But he said even at design temperature, it never activated auxiliary heat.
Because I mean, manual J on the cooling side is usually, it's within the range of equipment that we have to choose from.
Reasonably accurate.
Yeah, because you don't want to oversize too much because of humidity removal. If you oversize too much, then it won't remove any humidity. It'll short cycle. So
Yeah.
But with heat, I mean, if you got too much heat, then there's really not many downsides other than comfort. So
Yep.
manual J kind of fudges the heat factors more so than they do the cooling factors, but both of them there's enough fudge factors in there. If you do a semi-accurate manual J, then whatever it says and the equipment that you can select using manual S and the equipment selections that you have, there's no way you're going to undersize it. The only way it wouldn't work is if your ductwork was really leaky or really, really undersized, or it would be external from the equipment being adequate.
Yeah. But that's not the fault of the equipment.
No.
So
it's doing
in that
what
respect,
it can.
The manual J is accurate. It's the delivery system that's messed up.
Right.
Well, and
most contractors, if they do a manual J, they'll do a manual J and then they'll add another 6,000 BTUs to a ton to just to be safe, even though the fudge factors in manual J have that already built in.
Yep.
So you're oversizing it by 50% on top of 50%. So,
well, at the end of the video, when Alex, a fairly lengthy portion with Alex Meany and Corbett Lunsford, they both agreed that the best result is manual J, and then you true it to energy use.
mm-hmm.
Look at the utility bills, and that way you can
Boy, that sounds awful familiar.
It sounds very familiar. I think we've heard it here several times, often, regularly.
Probably because it's the most accurate way to do it.
Yes.
Wow, that's so one of the things that occurs to me is what these guys are arriving at is that load calcs need to be more accurate than manual J, or you end up having these problems we talked about where your equipment starts to fail.
Mm-hmm.
And predominantly it's going to fail because grossly oversized equipment is unlikely to have appropriate ductwork.
Yes.
Because most houses don't have oversized ductwork to the house's load. And so if it has oversized equipment to the house's load, that equipment's not going to be a match to the ductwork.
Yep.
And then you're going to have these problems. You're going to have problems on the cooling side. You're going to have problems with dehumidification because if you have oversized air conditioning,
Mm-hmm.
it's not going to run long enough to continuously dehumidify. And the newer equipment is even worse at dehumidifying, particularly if it's oversized, unless you get really good equipment that has reheat and all kinds of staging and is properly matched. Yeah. So I think where we want to take that conversation next is a situation where, okay, so manual J is the beginning of narrowing in on accuracy. Definitely not the end. And what's happened in the past is people have given the manual J this sort of deification of accuracy, scientific accuracy, almost cultish, like, oh, you need a manual J and this magical thing is going to tell you the right equipment. Whereas what we'd like to do is help people realize there's more interconnecting than just the load of the house from a manual J perspective. And in fact, the load of the house may be greater than the ductwork can manage. And one of the things that we found from all of these guys at Williams that were doing duct analysis is if you go to a duct analysis and match the ductwork to your oversized equipment, oftentimes that doesn't solve a problem either. Just like tightening a house with oversized equipment can make the house more uncomfortable, oversized ductwork can do the same thing. Do you guys want to talk a little bit about that?
I would have to get a better definition of oversized ductwork.
Well, so
let's say upsized ductwork.
So what I've heard from Ronnie and Austin is that from the duct analysis service that they used to provide, they would, as kind of a warranty service, like we're going to try and, or as a service to help people decide what their next steps are to fix problems with their house.
Yep.
Oftentimes adjusting the size of the ductwork without regard to the load of the house, because it's now prioritized. We're adjusting the ductwork to match the equipment without recognizing that the equipment's wrong for the load of the house.
Okay.
They were having homeowner problems that didn't get resolved after changing ductwork.
Sure. Well, that's what expression to use. Is it putting the cart before the horse? No, it's
fixing the wrong end of the problem.
It's based on a wrong assumption that the equipment is going to be okay if you upsize it.
If we fix the ductwork, the equipment's going to be okay and the house will be comfortable.
It's still going to short cycle. It's just not going to go off on limit.
Yeah.
Thank you.
And very often what it may do is heat the center of the house faster and the extremities
Never get any heat.
Yeah.
And that doesn't get changed just because you change the size of your ductwork.
Yeah.
And then there is the only real issue with like oversized ductwork. And it's really not oversized ductwork. It's oversized brand like outlets, like diffusers. If you go and you have quote unquote too big of outlets and you put in multi-stage or variable capacity equipment, then when it's on a lower stage, it's going to put more air out of the vents closer to the unit than it is out of the ones furthest away. So there can be some issues. Now you can always, block off half of the registers closest once you replace the equipment and balance it out. But there is some credence to that. But that's really the only thing with oversized ductwork. And that's really a distribution problem, not ductwork itself.
It's a problem with the terminal velocity. You're not getting mixing and spreading out through the room.
Right. And you'll see that in like older houses that have like old gravity registers and stuff that are huge and like
12-inch supply ducts.
Yeah, like the register's like 8 by 8x20 or something. Like you can push 3 tons out of that one register, so it's hard to balance stuff like that. But at that point, they really need to, if they're going to go with good equipment, they need to replace the ductwork and the distribution.
Yeah.
So.
Right. Hey, Tanner's
But,
joined us. Hey, Tanner.
Howdy.
There was one good video I watched over the week from HVACR school. It was like 3 engineers and Adam and that other guy. And they were talking about manual J and all the fudge factors and how you're splitting hairs when you're like, worrying about is the wall R15 or R13 or whatever. When you do the math, it's really not worth splitting hairs over.
Yeah, the squeeze ain't worth the juice.
Yeah, and they got into the duct sizing and stuff too. And they're like, we only have, it's not like we're putting in an 8.1 inch duct or an 8.7 inch duct. We either have 6, 8, or 10 for the most part. So
yeah,
there's only so much and manual J is just like that. It's based on a lot of assumptions, just like the manual D is. It's based on a lot of assumptions, and you can get as technical as possible figuring all this stuff, but when you finish it and look at the difference, it's really not that big of a difference.
Right. So I think that if we start talking about manual J as being the beginning of this accuracy funnel rather than the end,
mm-hmm.
it can be really a lot more helpful for people.
We should also consider that much of this is focused on existing houses, because if you've got a new house, you don't have any energy bills to use to refine the manual J. So the manual J may apply to new construction, and you actually have accurate measurements of the house.
Well, so one of the things that we're also seeing, and I'm open to people disagreeing with us, let's have a discussion, is likely load range probably gets you further along than manual J when it comes to sort of the accuracy funnel.
Especially when you have energy usage.
But even if you don't, because this is 90% of houses the same size as yours.
Yeah.
And so it's like, it may not be accurate to your house, but it's accurate to 90% of the houses. And then if the next step is to talk to people about, and by the way, unless you size in the green, there's a really good chance your ductwork isn't going to support the equipment, because generally houses, even in the green, they may not have sufficient ductwork, but a lot of times it doesn't take extraordinary measures to get insufficient ductwork to the point where green on likely load range is sufficient, is made sufficient through a bad drop or what have you. Some modifications right near the equipment, much bigger filtration. So I think like this first likely load range is probably the very broadest part of the funnel, which I think is where manual J lives. Likely load range is probably better than manual J because it gives people a broad funnel. It articulates the funnel to them instead of a point. And then green, yellow, red helps narrow that funnel for them and helps them understand the why behind why they might want to lean towards the green. And it's going to be duct, and it's going to be comfort, and it's going to be control, and it's going to be better dehumidification. It's going to be more efficiency. It's going to be less cycling, so the equipment lasts longer. It's going to be less hard on the equipment because the ductwork is more likely to match. It's going to be less hard on their wallet because if the ductwork doesn't match, probably doesn't require heroic modification to the ductwork or replacement of the equipment a second time.
And quieter.
And quieter.
Quieter operation.
And we're able to say to the homeowner, look, at green is where good houses are your size. If your house is mediocre or poor when it comes to weatherization, don't expect it to be comfortable even if you have oversized equipment for all the reasons we talked about leading up to this. That oversizing the equipment isn't going to solve that problem. So if you don't want to leave yourself exposed to having to replace your equipment a second time after fixing the house, then be willing to take a little bit of risk that the house isn't perfect and that you may need to spend a little bit of money fixing the house if the house is a basket case.
Mm-hmm.
And this way, at least you got the right equipment for this house when you bring it to the point where it's a good house. And if you don't bring it to the point where it's a good house, well, it was an uncomfortable house before anyway. So I don't want to hear the complaining.
I think the likely load range is a good conversation piece for getting the homeowner to understand and thinking about accuracy and all that stuff. But for me, I'm still going to run a manual J because it's really not a difficult thing to do. And it'll at least make me feel better about what I would recommend.
So somebody that has experience running manual J's and running blower doors and doing home performance, mm-hmm. I think is bringing a perspective to this that is kind of black belt-ish. And so you may do this, but your perspective is coming from a level of experience that most people don't have. And so if we're going to solve for the broader marketplace, we need to take them from a place of like not having a whole lot of knowledge or experience and being able to have the conversation with the homeowner at each step. Because, I mean, yeah, you can do a load calc and then you bring the blower door and get it more accurate. And then you true to energy use to get it even more accurate. And then at the end of the day, so what size equipment you putting on that 2,100 square foot house? 2-ton? Ronnie was telling me today about a 2-ton he sold somebody with a 2,100 square foot house. And the reason he sold him a 2-ton is because they didn't have 3-ton of ductwork. And by the way, if they had 3-ton of ductwork, he would have sold them a 3-ton because they're getting a 5-stage. And the difference between the 2-ton and the 3-ton is on the low end, the 2-ton goes down to 5,000 BTU, whereas the 3-ton goes down to 7,500. Both of those lows are like, is there that much difference to the homeowner?
No.
So, Tanner, what's you're usually good at interpreting and rewording stuff that these ideas that what's your take on this?
Yeah, so in terms of like likely load range and using load calc, really the way that I see the likely load range is you're giving a more transparent viewpoint of what a load calc without blower door is going to tell you anyways. So if you're not doing a blower door test, you can do a manual J however you want to do it. But at the end of the day, there is a discrepancy of leakage that can, cause that number to fluctuate greatly. And so unless you know what that number is, the only thing you can do is assume worst case scenario and assume best case scenario. And you're achieving the same thing with likely load range. And the whole reason that it's beneficial is that it's able to illustrate exactly what that is, like what a load calc without a blower door number truly is. It's nothing but an educated guess. And so we're just putting this educated guess into a more visual friendly method. So then that way, when somebody's looking at this, they can go, okay, well, without the unknown variable of leakage that we don't know, here's where it could potentially fall. And so if we're not going to pay to do the blower door test, well, then we have to decide, okay, do I have a good house? Do I have a mediocre house? Or do I have a poor house of the same size relative to other houses? And so,
do I want to oversize my equipment to what a good house looks like and oversize it potentially to the ductwork I got?
Yeah. And it's fine. Like if someone wants to use a load calc tool and do 2 manual J's of worst case scenario and best case scenario and use that to come to their number, sure, you can do that. It's just the question is it worth the extra time and effort to do that when you're just going to be coming to the same conclusion without it to begin with? Because we're still dealing with a large range. You
Right,
look
and
at
then you're
this.
still, and then you're not even able to articulate the green, yellow, and red aspect of this.
Yeah. Which you can use this likely load range and do the manual J's in conjunction. That's just the question is, okay, we're making we're taking a few step process and we're turning it into a 20-step process. And the question is that efficiency worth it? In my
Yes.
opinion, it's not.
Is that efficiency worth it?
Because it's, okay, let's say I don't do the manual J and I come to this conclusion and it takes me 10 minutes versus someone else does it and it takes them 40 minutes. I don't see them getting any other results that I am if we're both, coming to the same conclusion. It's like, what does it matter how we get there if we, achieve the same goal?
The other thing is, if you pick a point in here instead of articulating this range, you're actually doing people an injustice. Like if you get down to this, if you narrow the range and then you decide to pick a point, then your likelihood of causing harm by picking a point instead of articulating the range of risk gets really small. But out here, like I think what part of what I heard you saying, Tanner, is that doing a load calc, when you know that your level of accuracy is going to be potentially way off, the way as Corbett was saying in that video, like I think there's an ethical problem once you're aware of the range of inaccuracy of presenting what you're doing as having due diligence.
Yes. Because it's just putting a false sense of hope in that this number that you've spit out is actually true. Because and it's one of those things like once you see it, you can't unsee it, of being that when you run load calcs with or without blower door number and then watch run times to compare to see if it's actually true, and then you realize, oh wow, this number's off quite considerably on a consistent basis. It's so difficult to be over there in that order of magnitude section and to be able to pinpoint any particular thing and feel confident in it. Just because, when you've seen it be so far off before, it's kind of hard to still have that same, confidence in that number. And so really then what it comes down to is it makes it a lot more tricky, because at first it's like, well, doing load calculations, like that's difficult enough. And then you find out that when you do the load calculations, that number's not even useful because it's wrong most of the time. So it's just adding more complexity to how do I illustrate something that even I can't even quite get a grasp of. And I feel like likely load range is really the best option for that, is because you're able to illustrate the margin of error, and you're able to go, hey, like we really don't know where it's going to be. It's just all we know is here's the typical range of 90% of houses, and good houses fall here, mediocre houses fall here, and bad houses fall here. Where your house is, we don't know. You tell me what house you think you have. And so you're able to, be more transparent. And in my opinion, it has a better moral and ethical standing in being able to be transparent and not just go in and say, oh, I know exactly what you need. You need a 80K furnace with a 2.5 ton AC because I punched in some numbers in the software and it told me so.
Right. I don't know anything about your house. I never met you before. I've never spent any time here. I don't know what kind of complaints or problems you have because I haven't asked you any questions. I'm just showing up like a hero wearing a cape.
Yes.
Whereas, and in this case, since one of our approaches, one of the things that we do through our approach is offer duct pressure testing. This, when you tie it back to likely load range, helps the homeowner understand where they are. Like this, that further helps people understand, oh, at 44,000 BTU of my current equipment, it's oversized to a good house this size, and the ductwork is undersized to this equipment because of the static pressure. So I either need to replace ductwork if I go with the same size in order to get the static pressure down, or I got to go down in equipment size and take a little bit of risk that I may need to tighten the house up some if I have comfort issues on the hottest and the coldest days.
Yes. And it's really, and professionals are going to have a tough time with this part, but at the end of the day, when you're going on a free quote, the homeowner knows their house far better than you're going to know their house. Like it's just not even comparable. They might not be able to articulate it to you well, but they know their house way better. And so the audacity to just go in and tell somebody, I know your house better than you know it, and I've been here for 5 minutes. Now let me tell you exactly what you need.
It's infuriating. That's exactly the right word.
That's
audacity. So really where they're walking into this house is having this level of understanding, even if they do a manual J, which one of the things we know is manual J has levels of accuracy that can be improved. Did you measure the windows? Did you get the windows R value? Did you get their windows? Did you pay attention to how much solar exposure those windows have in the SHR or whatever it is, and calculate that? Did you measure the amount of insulation in the walls? Did you measure the insulation in the attic? All of this stuff? Did you measure the duct leakage? Did you measure the duct leakage to outdoors? You can't get over here without a whole lot of modeling work. And at the end of the day, do you even need to, if you know that the only place you're going to be able to help these people is downsizing the equipment so it matches the ductwork?
Yep.
Yeah, we probably all have stories of downsizing equipment, and the homeowner's reaction after living with it for a week or two is, the house has never been this comfortable before.
I can't believe how comfortable this house is. I never knew this was possible.
Yep.
You do have to get them ready for the fact they're not going to hear the equipment run.
Yes.
Because some people are going to say, I got a great sense of, security.
I
They
needed the
got
white
their
noise to
pacifier
breathe.
in their blankie
Yeah.
and the noise of the furnace running.
Yeah.
Now, on the other side, a lot of people are like, I'm so thrilled I don't have to turn the volume up every time the fan comes on.
Mm-hmm.
Yeah.
So, yeah, we got some comments on, oh, that's very funny. Jason, he's taking shots at your dogs. So, clocking the meter. Yeah. We actually, my preference as far as clocking the meter is having an Ecobee thermostat. Because, like, here you go, 30-degree outdoor temperature. This equipment looks like it's a rocket ship going off to the moon, and it's running like almost. This is 5 minutes, so 8 minutes an hour.
Yeah.
It's just that's grossly oversized, and I know that this is grossly oversized because this is one of my rental properties.
Is
So
he talking? Is he talking about clocking the gas meter, or
I think he's talking about
electric?
clocking the gas meter.
Yeah.
But this
Okay.
is in my mind, a much better way of doing it.
Yeah.
Because then you're able to look at outdoor temperature, indoor temperature, and run cycle.
Which
And I
I'm
mean-
not sure what the conversation was before I got here, but he could be talking about setting the gas input to the furnace, of just having the gas furnace set up properly.
Right.
Oh,
So, like if
yeah.
it's an 80,000 BTU furnace, making sure you're getting 80,000 BTUs of gas to the,
Right.
to set the gas pressure and such. But
And you'd need to know the heat content of the gas in your area.
Right.
So
yeah,
there's some fudge in that, in
Some
clocking the
variation.
meter.
Yeah.
And, I
Again,
mean, you're looking at a dial and trying to time it at the same time. So I mean, if you're off a couple of seconds, it's not the most accurate way, but yeah, it'll get you in the ballpark.
yeah, and that kind of information is sort of out here, which is beginning of the funnel. And yes, it's good. The more things that you can pile into the beginning of the funnel, the better you can start to narrow in.
Yeah. If you've got an 80,000 BTU furnace that's only operating at 70,000 BTUs because it's under fired, but you're going to you'll get a better idea of what your energy use is by looking at your gas bills. Disaggregate the gas bills so you know how much fuel you've used. Clocking the gas meter is helpful for accurately setting up the furnace to make sure that it's not overfiring and not stressing the heat exchanger because of that.
So, and maybe you do that because you don't have one of those good carbon
Combustion analyzer.
combustion analyzers. Because
Yeah.
wouldn't that sort of solve the clocking the meter for those purposes?
To some degree, but I mean, if you really want to be thorough, then you'd still clock the meter just to ensure that you're getting the input to the furnace before you start adjusting gas pressures and combustion.
And it could be
rates.
important if you've downsized and you want to make sure you're not underfired, so you don't leave them short of heat at the extreme temperatures. If it's a 40,000 BTU furnace and you're only getting 33,000 BTUs out of it, potentially, realizing that we're never getting 100%. But if they need 36,000 BTUs on the coldest day and they only get 33, that's where it'll catch you.
And I mean, that's more like Jim and Brian Orr's area, which would be like the commissioning of the equipment. It needs to be set up and commissioned using Measure Quick is the way I would prefer to do it, and the guided workflows will work you through doing all of that part of it. And once you get the equipment set up and working the way that it's supposed to, then it's going to do whatever the manufacturer says it'll do, as long as everything's within their specifications.
Yes.
And I wish that manufacturers would publish combustion analysis numbers like O2 numbers and stuff, which they do for some boilers, but not for furnaces.
When in a conversation that I had with the distributor's tech rep, and he serves 14 branches here in Ohio, I don't think anybody else that he's talked to in those 14 branches does combustion analysis.
That doesn't surprise me.
Which is telling me that the 99% of the contractors are slapping in equipment, making sure the fire is back inside the burners, and they're out of there. They get the check. By the way, he made me feel very nice one time when he was down working on a problem with us, and he looked around. This was a new house. He said, "Boy, you guys do nice duct work." So I had to congratulate the installers too. That was their
Yeah, right.
job on it.
So one of the things, Jason Cecil had to leave, but one of the things he mentioned to me is when he's out there doing sales, he'll oftentimes take pictures not only of the old equipment because it's in an attic or a crawl space and the homeowner's never seen it, but he'll also take pictures of the board and how it's set up, so that he'll be able to say to the homeowner, particularly if they've asked to go ahead and get the static pressure reading, he'll show them that the original installer never drilled holes, so static pressure has never been taken on that equipment until today, and they never set up the fan.
Oh, still on the factory settings.
Still on factory settings.
Yep.
And he does, when he does both of those things, it pretty much screws the pooch for whoever installed that equipment and whoever's been servicing it.
Yeah.
What if it was his company that installed it and has been servicing it?
Yeah, exactly. Right.
You go back to the office and find out who the service tech was.
Yeah.
You just said 99% of the contractors aren't commissioning. So.
Oh, well, that's Jason. And Tanner and Ted may have heard this before, but I was called in. It was a friend who had a separate building erected on their property, and the builder used his HVAC contractor, and the owners had asked they had the contractor back each year, and they said, "Was there any way we can get the basement not to be so cold?" They had a small apartment down there and some other stuff upstairs. And he said, "Nope, can't do anything about it." So when they had me go over, the first thing I looked at was airflow and found that sure enough, it was on factory default blower speeds, which was far too high for cooling. So slowed the blower, had to correct a few other things, but they said, "Oh, it's so much quieter." And it's not making, it's quieter, and the basement's not cold anymore. They can even close the vent in the bedroom in the basement without having it whistle.
Yep. And all you had to do was set it up.
Yep.
And it's not really
years
difficult.
and years they suffered with it just because it was not set up right.
She said, "I can't believe I waited 6 years to have you come look at this."
Mm-hmm.
Yeah.
Yep. It's pretty commonplace.
There were some other things that needed to be corrected too, but it was nice. And she even texted me a couple of weeks later to say it's just so much of a difference. It's night and day difference.
Yeah. It makes you feel good when you can do that.
It does. Yes. And it was nice of her to send that feedback.
Right. So yes, commissioning equipment is one of the biggest things that needs to be done when you install equipment.
The
When
factory
you
doesn't
install
know how
right
to
sized
set it up.
equipment.
The factory has no idea how it's going to be connected to the duct work and to the gas line and the venting. Yeah.
I mean, even oversized equipment, if it's set up to work the way it was intended, a lot of times you can make it a lot better than it was. I mean, because I'm sure the job Ken's talking about is probably
It was oversized.
Yeah, I mean,
not
if a generic install,
horrendously.
yeah,
it was
but
2 ton. It could have been 1.5 tons, but
yeah. So I mean,
and of course the 2 ton blower was capable of more than 2 tons of airflow.
Right. And they come on high speed because they know that 90% of the time they're going to get put on
undersized ductwork,
and they're going to have to overcome that. So they send them out on the highest speed.
Yeah.
Just to prevent the compressor from slugging or whatever, what have you.
Yep. Well, Tanner, we started off with heat exchangers. You got anything to say about those? Oh, you don't have furnaces in Alabama.
I wish we didn't, but we're still like 50-50. So unfortunately, I still have to deal with them.
Yeah. Okay. Do you see failures on a lot of them? Or perhaps a better question is, how often do you encounter failed heat exchangers?
Really not a ton, just because if someone has a furnace down here, they basically don't run enough for them to even have problems. So, I mean, there's some older furnaces that, just from being old and rusted out, that's probably the most common pathway. But the majority of the newer furnaces that you see, or I see, they don't run enough to even know. I mean, they don't even run long enough to trip a limit if, the airflow isn't right. They just, that's just what we typically see and run into.
Okay. You're not furnace territory.
Well, we have quite a bit of furnaces. It's just our weather shouldn't be furnace territory. And honestly, that's probably the case for a lot of people, really, is people can get away with poorly commissioning furnaces just because they're going to be oversized grossly to begin with. And so they don't run long enough for you to really see some of those problems, give issues.
Yeah. We're about 50-50 gas to heat pump. And I mean, there are a few days or a few, maybe 3 or 4 day periods every year, maybe every 2-3 years that they will run long enough to where those issues pop up. But in more northern areas where it might stay below 20 for weeks at a time or whatever, that's really where those types of issues happen. Where in our area, I mean, hell, by like right now it's cold to me outside, but it's probably like 35, and by tomorrow afternoon it'll be 65.
Mm-hmm.
So it's like,
yep.
Even if like people will go without heat around here, they won't go without air conditioning.
Oh, yeah.
Well, I feel like we're circling around, tighten up the narrative on accuracy funnel and using a range when you're in the beginning of the funnel, at least.
Mm-hmm.
Mm-hmm.
Yeah, I mean, like when going back to the manual J thing, I mean, I'm actually going to look at the attic and look at the windows and do as accurate as a load calculation as I can do without a blower door number to get as close as I can. It's still science. I mean, if you look at a load calc, the walls, the ceiling, I'm in a cool and dominant climate, so heat's not that big a deal to me. So ceiling load, windows, outside walls, the floor a little bit, but not really. And then infiltration and ductwork leakage outside the thermal envelope are really the only factors that are gonna swing it much. So I'm gonna do as accurate as a load calc as I can do, just because it really doesn't take that much time for me to do that. Now I can see
How are you doing it?
by hand. I mean, I've got most of the HTMs in my head, or I can do it on a program, but I don't pay for Wrightsoft or anything like that, because I mean, I did them by hand I can do them by hand as quick as I can put them into a computer program, and I actually know what my figures are that I'm calculating. So it's really not that difficult for me to do, and it gets it pretty close. But I see the value in having the wider range, but I also like to know where I stand at least, and then I'm gauging leakage too, like infiltration.
Are you gonna tell the homeowner what your load calc is?
No, but I would steer them more in a direction that I felt like what the house was more.
So you're going to take ownership of that equipment not being properly sized to whatever their ideal sizing requirements are. You're going to take responsibility for that.
Not for free, no. I mean, not without doing additional testing. But if I do a quick block load and I know it's pretty close, then I'm gonna guide them more towards the yellow or whatever, if they don't want to fix the house, or if they don't want to pay for me to go a little bit more in depth and do a room by room or anything like that, or any kind of duct design or anything like that. They're gonna have to pay for that.
I mean, you can do that. To me, what would seem to be the tricky part is it would get a little hairy once it becomes something to where you're not the one that's going out and doing it. So right now, you've done it enough. You feel comfortable with, hey, Miss Homeowner, if I'm going to steer you towards one direction or not, if you feel comfortable with kind of taking ownership in that little segment, and it's like, well, I feel comfortable here, blah, blah, blah. I mean, that'll be fine if that's how you want to do it. But if you want to, like, if you ever have to send somebody else out, I feel like you may have a little bit of, skepticism there of trying to get someone else to do the same thing that you're doing, and then you still feel the same, level of comfort in that same thing.
Yeah, I would.
Yeah, because now you're going to own that person's seat of the pants opinion.
Yeah, and I wouldn't trust that.
Yeah, because I mean, really what the likely load range is being able to offer you is to not have to give them a load calc or to give them a number, and to not have to go and try to sway them in any direction that you feel like they should go. Because as soon as you start trying to say, hey, Miss Jones, I think you should fall in this area, I think you should look at this, well, now she's going, oh, I trust your judgment. And whether she says it or not, if it doesn't meet the expectations that she's seeing, she's going to go, why did you tell me to go this route? You said I should downsize a few times, but now I have other problems, and now you're telling me that it was because my ductwork was in really bad shape. Why didn't you tell me that before I replaced this equipment? You can kind of run into those types of situations to where if you leave it more ambiguous and it's more of, I mean, you can go this route or you could go this route. We really don't know, if your ductwork's in bad shape or this and that, you can kind of be more in general. And if they're willing to pay you, well, then you can help guide them to a more, better specified workload or work scope they should be doing. But if they're not wanting to pay for it, any little thing where you're like, hey, I think you might should do this or you might should do that, they're hearing that as this is a recommendation that I think you should do this because this is what's going to be good. And if it doesn't end up being good, that's where the not happy people are. And so it sounds like you can probably handle that pretty well, like when you're dealing with homeowners directly and it's you that's doing it. You've done enough to where you got a good feeling, you got a good gut leaning towards what you want to do. But I would be a little probably worried if you were trying to send somebody else out to do the exact same thing that you're doing.
Yeah.
What's your take on that, Ken?
Yeah, I'm not going to do a load calc for somebody who's not going to pay for it. If they tell me that they need a bigger furnace or a bigger air conditioner, I'll try to steer them away from it. But yeah, I ask them what they want. If they tell me I'm the expert, I say, well, the experts don't work for free.
What if they sign the contract for the job and you're a good bit higher than them? Would you then run a load calculation?
If I haven't spec'd something and they've committed, they've signed with me, sure, I'll run a load calc then. I'll build that in knowing if that's what the plan is.
Yeah.
Well, yeah. But the tricky part there is it just kind of gets into if you do this, then why don't you do that? And if you do that, then why don't you do this? Because like with the comfort consult, it's like, okay, well, what if we just did a load calculation? And it's like, well, if you want to be accurate, well, you kind of need to do a blower door. And if you're doing a blower door, well, you kind of need to know how they use their house. What's their set points? And then if you're asking them what their set points are, maybe you just need to go ahead and ask them a bunch of other questions to see, do they do any other weird stuff? Do they have any other weird things? So it kind of just gets to that same.
Are there any rooms that are messed up? And maybe I should take pressure readings in those rooms to understand that, oh my God, I got a basket case room here.
And then it becomes a science project.
Well, that's when you tell them, I'm replacing your equipment. I guarantee it will provide this much heating, this much cooling. It's not going to fix problems that you have. If you have places that are uncomfortable, they'll still be that way. So just making it clear that new equipment does not guarantee making a house comfortable.
And I think that's the biggest thing is being upfront with them and honest and transparent.
Having that discussion.
Everything.
Yeah. We'll just make the offer of, okay, if like, are you looking for design? Because if you're looking for design, we have something that begins that process called a comfort consult, which is where I can gather the base information that's really needed. And anything between that point and doing nothing is that weird middle ground where, you're going to expect me to take responsibility that I'm not going to. And then when things don't work out well, you're going to be mad at me. And I don't want you mad at me. So I would prefer if we either do the comfort consult or if we do nothing, or being the free quote path.
Yeah. Clarifying expectations.
So, and this is where the free quote path can really help a lot, because it can allow the homeowner to understand and quantify the risk that they're taking instead of you taking that risk.
Yes.
Without having any idea of the risk that you're taking. As if you don't communicate to them these things here, then when they don't get a smiley face in their experience, and you haven't told them that they're not going to get a smiley face in their experience of that particular item, then you have to provide that smiley face.
Yes.
And so that's where the ideal specification comes in. It's like, look, we can get you anywhere in these columns with your ideal specification, with an understanding that I'm going to design for a good house your size. And if you don't have the smiley faces up and down the block, then the next step is to do a comfort consult because I know that if I get the equipment right and in the green, if there are issues, the issues are with the house, not the equipment.
Yeah.
And I'm not going to be exposing myself to replacing the equipment I sold you with smaller equipment, because that tends to be the thing that I'm seeing at these big companies like Williams, is they're going in and replacing big equipment with smaller equipment.
Yes. Well, I mean, really, the whole goal for us, or for me anyways, with the free quote is just to maximize efficiency for getting people good equipment. And in order to maximize efficiency, what I want to do as few things as possible to get to that point. And so,
It's
I
a
mean,
funnel.
you can do it however you want to. So there's like, I mean, like me, I'm doing absolutely nothing for free. And so I want to do as few things as possible. That's one way of doing it. And, you know, if someone doesn't like that way, you can do it differently. So if you want to do your free quote and you want to go and, you know, go do a bunch of free testing and you want to do some free load calculations, you want to do all this and build this spec and blah, 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 and build this free quote, like you can do that and you might get similar results. It's just, for me, I just want to do as less work as possible. And it's just, for me, it's efficiency is a big factor. And so if being efficient at your free quote process isn't super critical, well then, I mean, do whatever you want. Like go do, you know, you can go do multiple load calcs and I mean, you probably will get the same results. It's just, to me, the question is, was doing all that additional work worth it? Like, did that actually, you know,
Did you bring additional value to the homeowner or to yourself? And
yeah,
if the answer is no, then it's sort of a masturbatory exercise.
yeah.
Well, the bigger issue I have with quotes is not doing a load calc. It's having to give multiple like too many options.
And I love that you brought that up because
they're like, well,
what you're doing,
well, what about this? What about
right?
this?
What you're doing,
Can you give me a price on this?
what you're doing with the free quote process is you're telling them that you're there to help them build their ideal specification, and then you're going to give them a bid to that specification. So you're going to get basic, good, better, nearly perfect in your install choices and in your equipment choices. And that'll help them get in the neighborhood of their budget. And then once they're comfortable that they're locked in to the design that's actually going to fit their budget, then you can go and do the pricing, and you do it once. And my belief is that people that are doing more than one quote for free are doing what Tanner says is, I don't want to do that stuff for free. You get one free quote. And just to add to what he was saying, I will help you build your ideal specification so that if you're getting other quotes, you can get apples to apples. And the only thing I ask is that I be the last person in, because one of the things I've found is a lot of people can't build a quote that matches a specification, or they won't build a quote that matches a specification there because they're dishonest, and they'll be cutting corners on their quotes. So I would like to see that if I'm going to lose this job, I lose it to someone who is in fact going to do it to meet the specification that you decided was your ideal specification.
I just realized I was on mute.
That was a lot. That was a
Yeah.
lot. Right.
But the thing is, like with the ideal specification, like it really comes down to simplifying the message and being able to allow them to understand how to do this ideal specification. So like what Jason was talking about, with there being too many options, I don't think it's that there's too many options. I think that it's too much information that's just confusing.
Right. So, and they're asking for a whole bunch of prices because they're trying to get their head around it. And this separates that out because when they're asking for pricing, they're more towards the left of the funnel. And they don't
Yeah.
need exact pricing. They just need to get their head around what the range is to know whether or not it's a yes or a no for their ideal specification.
Yeah. Because, I mean, at the end of the day, most people, if you give them 4 options, they're going to eliminate probably 2 of the options. There's only going to be 2 that they're looking at because they're going either A, I don't want the cheapest stuff, so the bottom end is not an option. It's just, do I want the best or the second best? Or it's someone going, I don't have a whole lot of money to spend on HVAC because I don't care about it, so I'm only looking at the 2 bottom options. And so, do you really want to spend a ton of, I mean, granted, there's some proposal softwares that really simplify, doing multiple options all at once. But for smaller shops, you probably don't want to spend a ton of time, doing 4 quotes and then trying to send 4 quotes. And then you're sending a ton of information, which is confusing. It's this and that. Well, if you leverage the report, you can communicate the differences between 4 different options. You can allow them to go, okay, here's the price range of each one of these. Where do you think you're kind of falling? And they're going to go, well, I'm kind of looking at the good or the better option. I don't want the cheapest, but I don't want the most expensive. What can you do there? So then instead of having to put together 4 quotes, now you're just putting together 2. Or if you can get them to nail down onto 1, you only do 1 quote. And then they can use the report side by side with your quote while they're comparing everybody else's quotes, and then they can understand price differences as to why yours might be more expensive than others, because we all know most people only quote single stage. So if they ask for a better quote versus a good or a basic quote, it's going to be more expensive. So that way they can look at this, they can use the report and go, okay, well, I see why, company A, B, and C were $4,000 or $5,000 cheaper, because they're giving me this basic crap, which is what I told this other company I don't want. They gave me a quote to what I actually wanted. So their mindset towards you is automatically going to be better.
That's a lot, guys.
We're over time.
We're circling around this narrowing in on how to communicate to the homeowners and help them make good decisions.
Mm-hmm.
And I think if we realize that what we want to do is help them go down funnels of ranges, and then when they get to the final decision, that's where they need specific points.
Yeah. And
I need to figure out a better way of communicating that concept. Like, is this going to be your price range going over here? Is this going to be your price range ending up here? Is this going to be your price range ending up here? Mm-hmm. And that's what the free quote process tries to help people do. And one of the things, switching the equipment to below the install choices, was specifically to help with that, because people were picking the really good equipment. And then when they went to the install, they're like, well, I really want fresh air, so I'd rather maybe not get the best equipment. I'll get down, I'll get down a piece of equipment, and so that I can get the fresh air.
I was advised that a very good question to ask early on in the discussion is, what's your budget?
What's your budget?
Because if they think that they can pay for a Ford Escort and get a Cadillac, if that's, I spent $3,000 on my last furnace, so I figured it'll be a little higher, maybe $3,500. We can start with the money conversation right there before we even tell them
Yeah, and that's where these ranges help.
Yep.
That's where these ranges help, because
Absolutely.
if you want a big airdrop, then that's going to be a more expensive installation than if we're just going to keep the drop you got. And if you want fresh air scuttle,
Mhm.
that's going to be a couple of $1,000s more. And some of these decisions are going to mean, well, I guess you're not going to be getting the green speed. Maybe you'll have to get the 5-stage, or maybe you have to even settle for less than that and go with a crossover or a 2-stage. And that's where the install and then the equipment allows you get to here to this, ideal specification, because then, okay, that's your ideal specification. I can run the price one time. And I think we'll see people getting to the point where they charge the homeowner if the homeowner asks for an additional quote, because it's one free quote.
Yeah.
I'm helping you build your ideal specification. That's a really nice value added service. And all of these homeowners, the feedback from you guys come that are out there using it, is homeowner, particularly Jason Cecil. I got all those videos where I debriefed him. The homeowners' minds are blown, and they're incredibly grateful for that level of clarity and education. And they don't want to be abusive to him. They don't want him having to go, put together 18 different quotes so they can understand every aspect of the pricing.
Yeah.
But I guess some people have software that's very easy to do pricing. And so maybe, giving a couple of different prices is no big deal.
I think a big barrier is just the homeowner being overloaded with information. Just when somebody goes into that grade of detail, that they just have, it's just information overload, and they just can't wrap their head around everything.
Yeah.
They just don't understand it, because it's a lot to take in. There's a lot going on with a HVAC replacement and the house and everything goes along
plus
with it.
They think it's like buying a refrigerator, and so you come in and you start dropping these choices on them, and they're like, oh, this is going to be a little bit more complicated than I originally thought.
Yeah.
Yeah.
And then they want to see just like they can go to Lowe's or Home Depot and see the different refrigerators and the different options.
Right.
That they want to see the price tag, and they want to compare them, and which
right. That's not how it works.
The equipment manufacturers have websites where you can go and you can compare the different pieces of equipment, but I can't sit there for 4 hours and explain all this stuff to you. And I'm going to help you come up with your ideal specification, and I'm going to give you one quote. Yeah. So you just got to be a hard ass. This is what it is. Take it or leave it.
This is well, no, you can. I'm happy to give you more quotes. It's $25 a quote. Jason's going to be taking out air quality monitors and saying, here, you want to buy this so that you can track your indoor air quality? Here you go. You want
that's the way to do it.
CO monitor? Here you go. You want static pressure? 9 out of 10 people he's offered static pressure testing to have taken it.
Yeah.
So he goes out there and he makes money at the free quote.
Yeah.
Because he's getting static pressure. I think you can make money at the free quote by doing 2 bids.
Yeah, if he's selling add-ons at the same time too, then
right?
Mhm.
And I mean,
And the
for like
guys,
a
the
Haven,
guy's revenue per lead is like over $10,000. So he's killing it.
Yeah. It just comes down to the perceived value. I mean, when you're giving something of value being this report, and everyone else is just going, here's a piece of paper that says how much money you need to give me for me to do work.
Right.
The
Here's a piece of paper that tells you what I'm going to do to your house, and you can't decipher it because it's confusing as heck.
Yeah.
And at the bottom is the amount of money you got to pay versus here's a sheet of paper that explains the meeting that we had and the process that you went through to come to these decisions about what equipment and what installation you wanted. And then at the end, this is your ideal specification and what I would be happy to deliver your ideal specification for.
Yes.
Mhm.
It's nice, right?
Mm-hmm.
And I think one of the possibly most valuable aspects of this process is it's something that you could probably get a guy that you just freshly hired off the street to be able up and running in a week. Nobody's disagreeing with me?
I think
Nope.
it'd work. I think
Yeah.
it could work.
Yeah, so I guess it comes down to how good a job you did with your hiring. And in today's day and age, that's gotten a lot tougher.
Mm-hmm.
Yeah.
All right, guys. I think is there
I'm trying
anything
to
else
get
I
people-
end stream
I'm
so
trying to
we
get
can
people to
talk
take
after?
a bath.
Huh?
Like I'm trying to get people to use soap before they come to work. The bar's pretty low.
Hey, here's your soap budget. Here are your 4 bars of soap for the month.
Throw them a thing of right guard on the way out. Like,
Oh, jeez.
come on,
Here-
bro.
Give you a toothbrush. Give you
Yeah,
a toothbrush every.
got to put them on a commercial install just so they can hide somewhere and not be seen by it.
Just dangle an air freshener off the brim of your cap, Jason.
God, you gotta. Oh man.
Sounds like we're getting to the end, folks.
Gotta shame their parents. Thank you, everybody, for coming.
Yeah. Thanks, everybody.
Yep.
Thanks.
Yeah, that's true.
Uh-huh.
And we'll see you next week. And
All right.
See everybody.